All right, moving along to section 5.2, questions and show you know. The first thing in section 5.2, it says give the coefficient, the variables, and the exponent of each variable. So your first question gives you the monomial or the term 3c squared. What's the coefficient? Well, the coefficient in A, the coefficient would be 3. Let's make a table here. So the first term, 3c squared, has a variable of c. It has a coefficient of 3. It has an exponent of 2. Your second term, negative x, has a variable of x, a coefficient of negative 1. Even though it's not written, we know it's 1, negative 1. Just like if I knew that x would have a positive 1 coefficient, even though I don't write it, a negative x has an unwritten coefficient of negative 1, and has an exponent, even though it's not written, of a positive 1. In B, your variable, of course, is b. That's a tough one. Has a coefficient of 1, even though it's not written. It has a variable, or has an exponent of 1, even though it's not written. So technically, I could write 1b as 1b to the exponent of 1, but that would look ludicrous, so we don't bother. We just call it the variable of b. And finally, in st, you have a variable of s multiplied by the variable of t, squared actually. So you have two variables. They are s and t. S and t. Your coefficient is 7, and your exponent on the s is 1, and your exponent on the t is 2. Your second question is about the idea of like terms. And like terms is quite possibly the most important definition you have to know for polynomials. Because once you understand what makes like terms, every other thing we do in terms of addition and subtraction of those terms is going to make sense. But if you don't get like terms, everything else falls apart because it just doesn't work. So like terms by definition, I'll use my highlighter, are terms that differ only by their numerical coefficients. So you will know a term is the same as another term if everything about them is the same except for their numerical coefficients. And then it gives examples. 3x and negative 2x, the only difference between those two terms is the coefficient of 3 and the coefficient of negative 2. Otherwise, both of them have exponents of, or variables of x and exponents of 1. In these two, your y squares, the only thing that differs between them is the coefficient. They're both y squares. They both have the same variable and the same exponent. The only thing different between the two is their coefficients. And this one here, this is interesting because it looks like they're not the same, but they are. Because the coefficient for this one is negative 5, and the coefficient for this one is 1. But the order of the terms x and y and x is different. Remember, x next to a y means x multiplied by y. And if it was yx, it means y multiplied by x. And if y was 2 and x was 3, then xy would be 6 and yx would be 6. So the value doesn't change, even though the order of the terms does. So xy and yx are still like terms, even though the order of the variables is not. And what we learn to do is, when you have those types of terms, you should always keep them in alphabetical order. So if I was to rewrite this one, I would rewrite it in alphabetical order if I was copying it down. Because that way, just like if you have a fraction, you always express it in lowest terms. Or if you have a polynomial, you'll always reorder it in descending degree of terms. If you have a term that's not in alphabetical order with its variables, you should rewrite it in alphabetical order. And finally, the last one, 17 and negative 8 are both like terms because they don't contain any variables, and they're both just constants. So given that as a basis for the definition, it says give an example of 3 like terms. So obviously there's as many as you want to give, but I'm going to make negative 10x squared and negative x squared like terms. Or I'm also going to say 2x squared. All three of those are like terms because the only thing that's different about those three terms is their coefficients. This has this none here has a negative 10 coefficient. This one here is a negative 1 coefficient. And this one has a 2 coefficient. But the rest of the parts of the term, the variable and the exponents, are all the same. Another one we could have used negative xy. So here we have a negative 1 coefficient, a 10xy, we have a 10 coefficient, and why don't we go with a negative 3xy, a negative 3 coefficient. So those are three like terms as well. I guess that would be another example. And then if you wanted to do another one, let's make a complicated one. Let's make it 11x squared y z. Okay, that is a term. There is no addition and subtraction. It's just one term, and it is defined as 11 of these terms, x squared y z. There's 11 of those. And x squared y z means x times y times z. So that's one term. Another variation of that would be a negative x squared y z. That's a like term. The only difference is this has an 11 coefficient, and this has a negative 1. And we can even give this 0.5 x squared y z. In this particular case, the coefficient is not a whole number, but rather a decimal. And that is a possibility when we deal with algebra. You can have fractional coefficients or decimal coefficients as well. And your last question in this show, B says identify the like terms in the following group. So I'm going to use a yellow highlighter, and I'm going to start with this one here. Okay, 6t. Now what I'm looking for is I'm looking for other, in the four other terms, anything that just has the exact same t variable. And some people might think, well, hold on, there's one there. Those are like terms. But the answer is no, they're not, because they share the variable of t, but they don't share the exponent, which means there is no like term for t. There is no other term of the other four that has the same t variable. If we look at this one, and I'll use a green one here, there is 3s. So I'm looking for any other terms that have just an s variable with an exponent of 1, and we have one right here. The only difference between those two green terms is the coefficient of 3 and negative 8, which makes them like terms. Here, we have a t-square tile. There is no other t-square, so it stands alone. And the last one is your st tile. There is no other st's there. But if I was to say what is another term that could match with that, I could do negative 4t would be a like term for 6. I could go negative t squared would be a like term for the t squared, and I could say negative 10 st would be a like term for 6st if I wanted to. And your last part, which is what the culmination of all this information is about, is combining like terms. So when you have a polynomial, in this case 5x minus 3x squared plus 2x minus x squared, if I was to draw this out, here's what it would look like. So when I draw the first one, 5x is represented right here. So this 5x is here. This negative 3x squared is right here. This 2x is right here. And this negative x is right here. So what I'm really going to do here is I have a polynomial. I have four terms. I have 5x, a negative 3x squared, a positive 2x, and a negative x. But there are like terms. So for example, if I take my highlighter here and I highlight 5x, I have another like term over here of positive 2x. And what we're going to do is essentially, we're going to take those like terms. I better ungroup these. Hang on a second. Grouping, ungroup. No, ungroup. No, ungroup. Oh, for God's sakes. I'm not going to ungroup. Forget it. I'm going to take these 5 and these 2, and I'm going to combine them, and I'm going to make it into 7x's. And I'm going to put lines through them to show that I have taken those two terms, and I've combined them into 7x's. And then I'm going to take this term, negative 3x squared, and find the other like term that is also an x squared tile. And I'm going to combine those to make, I'll do it down here, negative 4x squared. And that technically is what this four-term polynomial has now simplified down to a two-term binomial. And the last thing I'm going to do is I'm going to look at both of my terms and decide which of the two terms that make up the binomial has the highest degree. It's this one here. So I'm going to rewrite it as the negative 4x squared first. And that 7x is actually positive. So I'm going to rewrite it as positive 7x. And that would be how you would gather the like terms from that four-term polynomial and simplified it by adding the like terms together or combining the like terms together. The second question, 2x minus 6 minus 2x plus 1 would look like this. So when I have this drawn, 2x is right here, minus 6 is right here, negative 2x is here, and plus 1 is there. So looking at it from algebra tiles, I know that my x tiles are the same. And here's the interesting part. When I put negative 2x tiles and positive 2x tiles together, it essentially makes a zero pair. So what ends up happening is those two and those two cancel each other out. So 2x tiles and two negative x tiles, whatever the value of x is, let's pretend it was 4. This would be 2 times 4, which is 8. This would be negative 2 times 4, which is negative 8. Together, those two would make 0, so they cancel each other out. The same way that 1 and one of these negative 1 cancel each other out, leaving me with simply an answer of negative 5. So when I simplify this four-term polynomial, and I gather the like terms, I end up with a negative 5 monomial constant term as the answer. And your last question is a 6-term polynomial. So I'm going to draw it. So when I draw this, oh, it's a lot of work. This is your k tile. This is your negative 2k squared. This is your positive 3. This is your 5k. This is your negative 3k. And this is your negative 4. And once I have that, I have to gather like terms. So the first thing I'm going to do this time is I'm going to start with my highest degree terms, which are these 5k squareds and these negative 2k squareds. So these two and these two are going to create an algebraic zero pair, leaving me with 3x squared, or sorry, 3k squared, not x this time, 3k squared as my k squared simplification of like terms. My positive 1k and one of these negative k's is going to cancel each other out, leaving me with two negative 2k's over here. And finally, my 3 and my negative 3 are going to cancel each other out, leaving me with simply a negative 1. So when I take this 6-term polynomial, and when I gather like terms, I end up with a trinomial, or a simplified polynomial of 3k squared minus 2k minus 1.